Good morning, boys and girls. My name is Mr. Mortara. I'm down in the basement, so you may not have seen me before if you have one of our other math teachers. But I'm here today to teach you about the inverse matrix, okay? And matrix inverses. Today we're going to work on being able to find the inverse of a 2 by 2 matrix by hand. And I'm going to show you how to find the inverse of 2 by 2 and 3 by 3 matrices. We're going to do this for square matrices again, just like we did the determinants yesterday. But I'm going to show you how to do them on the calculator as well. But let's first start with a little determinant review from yesterday, because we need to be able to find the determinant in order to find the inverse of a matrix. So if you remember from yesterday that DET stands for the determinant of a matrix, and the determinant again is a scalar number that tells us about the matrix itself. And to find the determinant, we're going to follow, for a 2 by 2 matrix, we're going to follow this little rule right here. You multiply along the diagonal that goes from the top left to the bottom right, so A times D, and then you subtract the diagonal that goes in the opposite direction. So going from top right to bottom left, I'm going to subtract B times C. So that's how we find the determinant again, real quick and easy. Generally, with the 2 by 2 matrix, I would not use my calculator. It is much faster just to do it by hand. For instance, on number 1 here, if I want to find the determinant of this matrix, I would do 3 times 1, multiplying along that diagonal right there, minus 2 times 1, multiplying along this diagonal right here. Okay? Then I'm just going to work that out. 3 times 1 is 3, minus 2 times 1 is 2, and so 3 minus 2 is 1. So the determinant of that matrix would be 1. All right, on your own real fast, I'm going to let you go find the determinant of matrix N. I'm going to give you just a few seconds. You might want to pause the video so you can do that, and then once you unpause it, your answer will pop up and you can check yourself. Okay, so when you multiply, you should have done -1 times -7 minus 9 times 4. -1 times -7 is 7. And then 9 times 4 is 36. And then 9 minus 36 is -20, or 7 minus 36 is -29. And so that'd be the determinant of matrix N. Okay, now, again, we reviewed determinants so that we could use this to talk about the inverse of a matrix. First, I'm going to scroll up here a little bit. Let's talk about what an inverse is. I'm going to change the definition we have going on here a little bit. I think this is the definition we're going to use later on in the year when we talk about inverses. But I want to talk about them more generally. So I'm going to kind of erase and write something else here. Okay, so the definition that I'm going to use of inverse is actually the English definition. If you were to look this word up in the dictionary. And the inverse is something that is the opposite or reverse of something else. Okay? In math, when we talk about like addition, its inverse is subtraction. That's the opposite or the reverse of addition. Okay? Multiplication, its inverse is division. That's its opposite, or it reverses multiplication. Okay. With matrices, the inverse matrix is the matrix that is going to it's going to help us undo what a matrix does. Okay. You'll see more what I mean by that when we see tomorrow's lesson and we start using inverse matrices to help us solve a matrix equation. But just know that the inverse, again, undoes, it reverses what we've been trying to do. Okay. When we talk about inverse notation, when I want to notate an inverse, again, we talk about a matrix, and I can just call a matrix A, matrix N, matrix B, whatever. For the inverse, we're going to raise it to the negative first power. Or it looks like we're raising to the negative first power. A to the -1 notates the inverse of matrix A. Okay? So a little -1 sign means inverse. All right. And so an inverse matrix is a matrix that we multiply another matrix to get what we call the identity matrix. Okay? The identity matrix. And so what's the identity matrix, you say? Well, the identity matrix is a square matrix that is the equivalent of 1. If you multiply a matrix by the identity matrix, it's not going to change what it is. Any matrix I multiply by the identity matrix, it's going to give you the same matrix back. It's like multiplying by 1. 5 times 1 is 1. 7 times 1 is 7. Did I just say 5 times 1 is 1? 5 times 1 is 5. 7 times 1 is 7. Okay, when I multiply by 1, it doesn't change what it is. It doesn't change its identity. Okay, so same thing with the identity matrix. If I multiply by the identity matrix, it will give me the same exact matrix back. Okay, it doesn't change it. When I look at the identity matrix, we denote the identity matrix with an I. Okay, so we save I for the identity. And it's got zeros everywhere except ones along the main diagonal going left to right, top to bottom. Okay, so it'll always have ones along this diagonal right there. Okay, but everything else is going to be zeros. That's the identity matrix. If it was a 2 by 2 matrix, it would look like this. And again, it's always a square matrix. Okay, that is also the identity matrix. Okay, so now I think we're ready to go ahead and find the inverse matrix of a 2 by 2 by hand. Okay, to find the inverse of a 2 by 2 matrix, again, this little -1 here denotes inverse, right? You see a matrix of the -1, that means inverse. To find the inverse of a matrix, here's our rule. You're going to do 1 over the determinant. Okay, 1 over AD minus BC. That's how we find the determinant, right? AD minus BC. Okay, so 1 over the determinant, 1 over AD minus BC, times this new matrix. To get this new matrix, what you're going to do is you flip along this main diagonal. So I changed A and D. I changed their position from the old matrix. And then along the other diagonal, in this direction, they're going to stay in the same spot, but you're going to change the sign. So it went from a positive B to a negative B, and from a positive C to a negative C. Okay, so we're taking our original matrix and we're flopping it along the blue diagonal, and then we're changing the signs along the pink diagonal. All right, so that's our formula to find the inverse by hand. Let me show you how it kind of works here. Okay, so number 2, if I want to find the inverse of this matrix, raised to the -1 of that matrix right there, I first am going to go and do 1 over the determinant. So 1 over 1 times 3 minus 0 times 4. Okay, that's going to give me the determinant. Then times, for the matrix again, along the main diagonal we call it, I'm going to flip those values. Instead of 1 and 3, now I get 3 and 1. I'm going to change their position. Then along the other diagonal, I'm going to change the signs. So this would be a -0, but -0 still is 0. And then I'm going to change it to a -4. Okay? And then I'm going to want to multiply, find my determinant and multiply this stuff together. 1 times 3 is 3, and 4 times 0 is 0. So I get 1/3 times this new matrix. And now I just need to do my scalar multiplication, and I'm going to multiply everything by 1/3. 1/3 times 3 gives me 1. 1/3 times 0 is 0. 1/3 times -4 is -4/3. And 1/3 times 1 is 1/3. So this is our inverse matrix. Okay, that is my inverse right there. If I were to multiply these matrices together, the original one and our inverse, it would give me the identity matrix. Okay, and the cool thing about this, we talked about when we multiply matrices, how there's no such thing as a commutative property. The order that we multiplied in was important. With inverses, it doesn't matter the order. It'll always give you the identity matrix. So that's kind of cool. All right, let's try 3. So we're going to start by doing 1 over the determinant. 1 over 4 times 4 minus 8 times 2. Times, again, what I'm going to do is I'm going to flip along the main diagonal. So when I flip 4s, they're still just 4s. And then the other diagonal, I'm going to make them negative. It's kind of weird in the beginning, but once you get the hang of it, it's actually quite easy to do. Okay. In this case, though, when I do the determinant, 4 times 4 is 16, minus 8 times 2 is 16, I get 1 over 0. Now, this is an issue because we cannot divide by 0, right? That's a bad thing in math. If you get 1 over 0, if your determinant is 0, that means the determinant does not exist. And so that means the inverse is not going to exist. Okay? So in this case, there is no inverse, or the inverse does not exist. All right, on your own, go and try to do B, and again, you can check your answer. Again, pause for a few seconds, do B, and then unpause it and see if you set it up correctly. Quick check-in. You first should find the determinant. It should be 1 over 6 times -2 minus -1 times 14. If you got that right, good job. Now go ahead and set up your matrix. For your matrix, again, along the green diagonal, you're going to rotate those numbers. So -2 and 6 switch spots. And then along the blue diagonal, you're going to just change the sign. If it was negative, it becomes positive. So it becomes a +1 and then a -14. Now, again, check yourself. Go ahead and multiply your answer and see if we come up with the same answer. And you should have got -1, 1/2, -7, and 3. Okay, that is our final inverse matrix. All right, so you can see a 2x2 matrix by hand is not very bad. A 3x3 matrix by hand is so nasty. I'm not going to even show it to you. Okay, what I am going to show you is how to do this on your calculator, so you can check yourself with a 2x2, or you can do 3x3s or any size, any square matrix on your calculator. So first you're going to do is pull out your calculator. Okay, I've already done this here, but the first thing you should always do is clear your calculator. So again, quick reminder, if you do second, plus sign, 7, 1, 2, that resets your calculator so that, again, everything you get is going to be brand new now, especially if you're borrowing one of the calculators in class. You're going to want to go to the matrix menu. Okay, so second matrix under the math button. Again, if you need more help finding this menu, go back and see the day 1 video, and you're going to go over to edit, and you're going to enter the matrix into A. In this case, we're going to do a 3x3 matrix, so I put those dimensions in, and now I'm going to enter in all of my entries. I always tell my kids, be very careful when you're doing this part, because so much of what we're doing is on the calculator. If you mess something up, just entering your matrix in your calculator is going to mess up all your answers. So when you're done, quickly go back and check all your entries. 4, 5, 8, 2, 5, 6, 9, 4, see, and this is why I do it. My entry is 14. I only entered a 4. The 1 didn't stick for some reason, so I got to quickly go back and I want to fix that. 14. See, for some reason my 1 doesn't want to work. See, now I'm trying to do 41. 14. But make sure you put the matrix in correctly. Alright, once you do that, you want to second, quit, and go back to the main screen. Now, you're going to go second, matrix, and grab matrix A, the one you just entered in there. And to do inverse, it's really easy. It's the matrix button without the second. If you look on there, it's got the -1 button. So if you just hit the -1, this will give you the inverse matrix. Now, in this case, oh my gosh, that looks ugly. That does not look friendly and like something we want to deal with. So what we're going to do is, those are decimal answers in math. Hit the math button. We like fraction answers. So 1, again, will turn everything into a fraction. So the arrow frac will turn my answers, all these, into nice, happy fractions. And now there is my inverse matrix. All you got to do now is copy down your answer onto your sheet or on your test, and voila, you're done. That easy. All right, let me show you just one more time. Let's do it with this 2x2 matrix. First, you got to enter it into your calculator. So again, you're going to go second, matrix, and over to edit. In this case, I want to make it a 2x2, so I adjust my dimensions. Now I got to type in my new matrix. Again, when I'm done, I'm going to double check to make sure I didn't mess anything up. And then I'm going to hit second, quit, and go back to the main screen. Okay. Now here's the cool thing. If you've already done one of these, you can just hit up. If you just type that same matrix like I just typed it into A, I can just go back up till I find that A inverse and hit enter. And I can just hit enter again, and I'll take the inverse of A, which now again is that new matrix. You can see my answer is different. And if I hit math, frac, it will give me the fraction answer. And now all I got to do is copy it onto my paper. Okay, there we go. On your own, really quick, go and try C. Again, pause this, and you'll be able to check your answer. All right, this one's not so nice to write down, but there's your answer, boys and girls.